it's a great pleasure to talk to you. I'm going to be talking about why energy is exciting. And, if you look around this room, there are things in this room that we sort of take for granted, that were invented, the way we do things, the way we implement things were invented 100 years ago. And we don't question, we just take it for granted, right? Why does the window look the way a window does? Is there something we can do with the ceiling? The one example I use is the windmill, right? This is an old Dutch windmill. And why does it look like that? Well, very creative Dutch folk invented it. But then we get into what I call frame inertia, which is we form a frame of reference, and then we think of everything that way. And it's very hard to get out of that frame of reference and think differently. But not anymore. I think we are now being forced to question everything, everything around us. So if you look at windmills, there are amazing inventions around the world today. This is a company called Joby, which is based in California. I just wanted to, I'm not plugging Joby per se, I'm not sure it necessarily works, but it's a crazy idea, right? Which is the wind velocity is much higher at a higher altitude. Once you get to a higher altitude, essentially by putting turbines on a kite and flying the kite high, right? And that is the sort of breakthrough, frame-challenging inventiveness that we are now beginning to see unleashed. And it's a very exciting time for many of us. So for example, I have a student, and he's working with Professor Alex Slocum at MIT. And he is working on taking, so the idea is to make towers for wind turbines much higher, so you can capture more wind. And the problem with that is shipping costs, manufacturing costs, et cetera. And he's invented this way of doing in situ seam welding in a spiral form to make much taller towers. And you can go to his website and you can figure out how much more efficiency or how much more wind capture he gets out of it. But the implications are enormous. But again, you look at a tower and you go, well, that's a tower, right? But if you really look at it, you go, why can't we make it taller? Well, it's manufacturing constraints. How can we fix that? And you start questioning, and you invent things that you didn't think you had a right to invent. And that's really the world we're entering. So let me give you a quick, just to walk through some of our the startups in my lab, from my lab, but also around MIT. I see Adam Paxson there, who did his undergraduate degree with me and has a wonderful startup, Dropwise, which was mentioned earlier. So this particular startup, ESS, which you'll hear about in a minute, came out of, I had, some of you may know a company called Next Step Living. It's a local energy auditing company. They came over to my house, they're friends of mine, and did an audit of my house. And I thought, that takes 6 hours. They did a great job, really helped me a lot. Now, and they've used an infrared camera indoors. So I thought, why not do it from outside, because you can see the same leaks from the outside. And then I thought, maybe the best way to do it might be, think of Google Street View, right? What if we could do something like Google Street View, where you have a car and like that, which collects images, except use infrared, and you can collect at massive scale. And so that's how we conceived of the idea of, it's not advancing, can someone advance it? Just advance it for me? Thanks, yeah. There you go. So the idea was, why didn't we take long-wave infrared cameras and pair them with other imaging techniques, such as near-infrared, optical, regular EO, electro-optical, and so on. And we essentially invented a new rig which sort of does what Google Car does, but except in the night, using long-wave infrared. So the two founders of that company were in my lab, and we founded the company. We first called it IR, E with EYE and then R. That we thought was sort of cool. Anyway, and then we changed the name to ESS, for SS with an E, right? And this company, what it does, as I said, is if you can advance that movie. So we drive around in the middle of the night with near IR and long wave infrared, take images. I'm going to go to the next slide if you can advance us in the interest of time. And now play that movie as well. The technology is very, very advanced. So not only do we do near long wave infrared, we also do LiDAR. So essentially we have all the technology of a Google car. And so we can reconstruct a 3-dimensional image of of the streets as we walk by, as we drive by. And we merge all that information, and we can overlay it, sort of like texture mapping on 3D. We can overlay infrared and figure out where the heat leaks are occurring, whether it's the chimney or the roof or the soffit or the band joist, and we can do it all automatically, right? It's like image recognition, it's like face recognition, except we're looking for features. And the great thing, as I said, is it's all super high-tech stuff. It's the sort of stuff that gets us up and going here at MIT in the morning, right? And the technology making the stuff work is not easy. But once it works, the scale is really great. Of course, this has other users as well. If you can go to the next slide, it seems to be in a loop. And play this as well. This should be a movie, right? So the way it works is that you log into ESIS if you're a customer and you get a report. You can see how your home is doing, right? You can get a street view image, a video of your home, and you can figure out whether you want to have it fixed or not. The amazing thing about heat is when it leaks, you can't see it, but really it's like dollar bills flying out of a little hole in your home, right? So we make that visible. Okay, so if you go to the next slide, yeah, thanks. But it doesn't stop there. If you can do that with heat, what can you do with energy for detecting energy loss in other arenas? So one of the projects that we did actually funded by Ferrovial, I saw Rob Stoner a little bit earlier, from Mighty. And Mighty's been a really incredible initiator of great creativity around MIT. A lot of the projects that you see mentioned here really came out of Mighty. They gave us the seed grant through Ferrovial. Ferrovial is a Spanish company. Enrique was involved in that as well. And what we ended up doing was we said, so Ferrovial is a company that does streetlights. They take over contracts with like the city of Birmingham, et cetera, and they manage streetlights. It's a sort of a public-private partnership. And they said, we don't know which street lamps are over-illuminating the streets, which are under-illuminating, which lights are broken. We don't have an inventory of what sodium vapor, we don't have all that information. We also want to figure out where to put LEDs in. So what Ferrovial does is it buys out a 10-year contract and replaces light bulbs with LEDs, and they keep the savings. So the city's better off, they're better off, the environment's better off. But they needed to map all this information, and the inventory is really bad. So they came to us, and a bunch of students and I, we brainstormed, we said, imagine if you could take like an Android phone with a camera, put it on top of city vehicles like police cars, utility vehicles pointing upwards. Right now, Android phone has GPS. So strictly speaking, just by taking those images and stitching them together, you should be able to reconstruct a map, if you do it in the night, of where the lighting is and where it isn't. So that was this project. And what we can do now is construct very, very accurate street lighting maps. And we sort of crowdsource it. It's not crowdsourced in the sense that we don't enlist the common citizen, but we use regular city vehicles. And as city vehicles ply the city, we're constructing maps. And it's real time, sort of semi-real time. So we keep updating the maps. So that's another very simple thing that we can do today that we couldn't do even 5 years ago because of the unbelievable improvements in imaging, computation, communications, sensors, GPS, right? All come together. We were able to do LiDAR in the previous example because Google and others are doing LiDAR. The cost of LiDAR has come down. Now if you have LiDAR and you have imaging, can you stick it on a drone? I'll come to that in a minute. And then what can you do with that, right? Amazing things you can do with it. So the bottom line, I want to keep it very short, my presentation, is everything can and will be rethought. Sensors are everywhere. Sensors are extremely powerful, right? Another company that came out of our group is a company called Senaya, which does asset tracking. Every boiler, that consumes energy, we should be able to measure how it's doing. We should be able to measure energy input. We should be able to measure heat leaks. Again, combining temperature sensors, thermistors with communications using infrared. And we should be able to build a much more responsible ecosystem that sort of creates a safety net, an energy safety net over everything we create and build so that we don't, A, let dollar bills sort of fly out of the window, but also let CO2 or other emissions fly out of the window if we can possibly help it. So I just want to mention briefly another company that came out of our group, which is a company called Top Flight. So this is a company that does drones. And it's sort of interesting. It's circular. I'll tell you what the circular story here is. So drones are sort of a very hot thing today. You know, you have companies like 3D Robotics. They've all raised a lot of money. Everyone's talking about drones. Here's the problem with drones. The problem is they are electric. The way drones work today, and the reason quadcopters especially are very popular is if you take a helicopter, the mechanical engineering of the collective, et cetera, is very heavy and expensive. The reason a drone works, especially a quadcopter, is it's 4 motors. It's like a Tesla car. It's 4 motors. And the transmission is electricity, right? So you want to change something, it's all electric. So it takes the transmission away from mechanical engineers, which is a sad thing for me, puts it in the hands of electrical engineers. Fantastic. That's why quadcopters are so light, and that's why we can do so much with them. Here's the problem. The problem is battery technology has not kept up with all the other technologies. Battery technology is going like this. And the fact of the matter is, you can get a hang time of more than 20 minutes with a regular electric drone. So for all its great promise, there's only so much you can do with drones. Okay? Now, batteries have become cheaper because of Tesla and their big battery, the new plant they're building, et cetera. But in terms of power to weight ratio, in terms of energy to weight ratios, they're not there yet for drones. So here, one of our students from my group said, why do we need to use batteries? So what he did was build a very small hybrid engine. Because if you look at energy density, a hybrid engine trumps batteries any day. Gasoline, the energy density of gasoline is an order of magnitude greater than batteries, right? So what he does is he has, like a Honda Insight, he has a hybrid engine. It's a combination of a regular engine with a generator and a battery. And with that, he gets a drone, and he can actually fly it for 2.5 hours, right? So that's like an order of magnitude greater. When you do that, the implications, especially in infrastructure, things like pipes, et cetera, are enormous because you can put sensors on these things, you can track pipelines, you can inspect equipment, you can do 3D mapping, all the stuff I talked about before. Now you have yet another vehicular modality to do it at a large scale. But the final point I want to make is I started by pointing at a window, right? Can we reinvent the window? I argue it's a matter of time before we do. It is a matter of time, right? You just have to stare at it long enough and think about it and be a little bit wacky, and someone's going to figure out why the window looks the way it does, what the problems are, and how do we reinvent it. An example of that is this company Tessolar, which I met one of the people involved in it the other day, and he was describing to me how they're rethinking the way in which solar panels are made. I know there's a Tessolar person here today, right? Hey, yeah, Jaco. I met Jaco. Yeah, so I was talking to him. I thought this is such a fascinating idea, right? There's no technology in a solar panel, yet we find so many ways to screw up the ways to make it. And these guys have some really great ideas of how to improve it. Coming back to drop-wise, can we impact something as fundamental as the way in which drops interact with surfaces? Turns out yes. Can we change the friction of a liquid with a solid? Turns out yes. There's another company from the same group. This is Kripa Varanasi's group called Liquiglide, which you may have heard of before. We are entering an era of really fascinating possibilities. And I was very inspired by the earlier presentation by Corey from Saudi Aramco because there's a great opportunity here to take these technologies. The problem is the energy barrier between having an idea and bringing it to implementation. And we can find a few forward-looking companies that are willing to give them a shot at whether they work or not. I think that we can really, hopefully, I think have some really incredible breakthroughs and catch up in this terrible race we are with climate change. So thank you very much, and I'm happy to take any questions.